design principles that we always try to keep in mind. The first one is KISS. Keep it super simple. The simplest option is usually the best. And we have had to relearn that several times from personal experience. Tool design first, then you program the robot to use the tool. This is so you're not trying to fix hardware or mechanical problems with software. You want the good hardware first, and then program your robot to use that hardware well. Leapfrog development for tools and programs. This is our method for step-by-step improvement. We build a better new tool or program before we take apart the old tool or change the old program. This is so we never end up going backwards. And what this principle does for us is if we have something that works and we want to try to improve it, we build a copy of it and modify the copy of it. So that way, if that change makes it worse, we've still got the one that works. And we were talking with a few of you guys this morning. We actually have two very similar robots from Ring It Up over there. This principle is why we have those two robots. One of them is the earlier version of the other. And the earlier version, it worked well. It wasn't as good as the newer version. But there were some things we wanted to change. We didn't know necessarily if those changes were going to help or not. So we changed our second robot with those new modifications and just saw which one worked better. The changes either worked or they didn't. And then repetitive testing.
We test repeatedly to make sure everything works 5 times in a row.
And then competitive development. We try several options and the best one wins. Everyone at least on our team in general, has different ideas of ways the same thing can be accomplished. So rather than just talking it out, we actually prototype and build each individual idea and then test them against each other. And whichever one works the best, that's the one we go with.
So, a question on the leapfrog development. You built 2 robots this year?
Not exactly. That's a good point. What we do is we start off, we build our first robot, get it to a functional state. We build our second robot. When we want to change, when we have a change we want to make, we change that second robot. Well then, now we've got a new change we want to make. Change the first one, get it up to speed with the second one, and now get it ahead in its own new way. So we keep going back and forth. So those are probably generations 6 and 7, something like that, of our robots. But they just keep alternating back and forth. So we always have one that is working and works well, or as well as they have worked so far.
You stay primarily within the Tetris build system?
For our chassis we do. Past that, we actually do a lot of custom parts as well as other cots that we're allowed to use.
Meaning, basically, we've got our chassis, it's pretty much all Tetris, but we use drawer slides, turntables, and then we do a lot with sheet plastic. So, PETG, polycarbonate, impact modified acrylic, and Delrin. Those are our 4 main ones that we use. And with there, you can bend plastic to get 3-dimensional shapes, cut it, form it, whatever.
I'd like to ask the guys to briefly talk about screwing up design principle number 1. Oh.
So, in your competitive development space, have you ever had a case where two competitors didn't really agree which one was the best? And then what do you do about it?
It's another thing, or another kind of objective. We try to be really objective.
Generally what we do, we'll have the two of them compare it, and we'll always base it off if it's points and say, okay, this one scored more points, so this one is more reliable, we'll pick that one. We'll also usually have a third person looking at it, so it's not saying, no, mine's better, and another guy saying, no, mine's better. So we try and keep it as objective.
And that combines also with your repetitive testing. We don't play them against each other once. If it's a toe-to-toe thing, 5 toe-to-toes. If it's placing a ring at a desired height with more speed, 5 tests with robot A, 5 tests with robot B. And the decisions are almost always made without any potential for personality because we've designed, honest to God, success criteria for the test. Does this one do it faster? Does this robot push the other robot? And if you can take the emotion out of it, you're both getting a better result and you're teaching these guys to be better engineers.
So,
Yep. So other questions? Anything else on this one?
So does your team have a cutoff point where, say, 2 weeks before a competition, you stop working on hardware and only do software and testing?
yes, sort of.
It depends.
What we do is when we're looking at, when we first get we go through kickoff and do our game analysis, we say, this is our timeline until our first tournament. And then we set our timeline to be done usually 2 weeks before then. And from there we say, okay, and we act as if that 2-week point is hardware has to be done by then. And we build with that assumption in mind. And then we have those last 2 weeks for programming, testing, tweaking. If we get to that point and we say, okay, this really isn't working, then we can play with that deadline a little bit. The other thing that we do is we program throughout the entire season. So a couple people will be building. I'm the programmer for our team, so I'll be working on getting the drive code ready to go so we can just drop it onto the robot as soon as it's done. If we have certain calculations that need to be done in the program, like we had an ARM-based robot earlier this year, I spent the majority of my time trying to figure out that math and get it into the program in a state where it worked, while other people were building that ARM.
Another thing you want to do is drive practice. A lot of teams, they don't practice their robot driving until they get to the tournament, and then they don't have a good idea of how to do it. So a lot of times what we'll do if someone's building a new part, the drive team might be practicing driving the robot. So you always want to at least practice some before the tournament so you can be ready when you get there.
This is sort of on tangent, but how many hours a week do you guys spend? Just curious. 14 hours?
Well, it depends.
Later in the season, we start spending more time in practice. I mean,
It started at 12.
It starts at 12. I think it's gotten to 14 or 15 near the end of the season.
That's a quick example. You have more resources than most teams, as you robots over there. How do you apply some of those principles to if you only have?
You do what you can. I mean, if you have less resources, then rather than building an entirely separate robot, you might be building just two different versions of one manipulator. We are fortunate enough to have some good sponsors, and that allows us to have 2 robots, full robots. Our first year, we didn't start off with 2 full robots. We would do one individual component on that robot, get it to a working state, and then maybe even disassemble the duplicate so we could use the parts for something else.